Okay, so finite difference, okay, for this kind of differentiation, okay, we call it finite difference method, okay. So first thing first, we need to what is that? We need to call out this Visual Studio 2019. Okay, create a new project, console app. So this is finite differentiation. Okay, create. Right, so I'll delete everything. Okay, I'll start everything from scratch. So the first thing, as always, okay, include IO stream. IO stream, right? And then we will need to use mathematics. So include CMath, right? So if you want, you can include IO, manif, okay, things like that. If you want to write the result in text file, you can call in what is that? Include fstream, right? But I'm not intending to use fstream for this one. So this one using namespace std, okay. All right. So and then this is integer main, right? Okay. So this is my main function. So okay, let me introduce you what is finite difference. Okay, so numerical differentiation with C++. Okay, finite difference. Let's say you have a polynomial. You have a. It doesn't have to be polynomial. It can be any functions. Okay, mathematical functions. So the mathematical function is represented by this line. Okay, the blue line here, the blue curve. Okay, so let's say if you want to take the differentiation at this point. Okay, differentiation means the slope, right? The slope of on a curve at a specific point. Okay, let's say x, you want to take the differentiation, the slope at this point x. Okay, so this fx is the curve. Okay, so the x is the point that you want to evaluate. Okay, so in order to find the slope, okay, you have to create a point. Another point near the point that you want to evaluate, so that you can draw a straight line. Okay, then you can find the what is that dy over dx, correct? So the slope, the definition for slope is dy, okay, dy over dx, right? Okay, so if you create a point here, okay, at the offset, okay, at some offset point, okay. So this offset point, you have to make sure that it's very close to the point that you want to evaluate. So this is just an exaggeration. Okay, just want to show you how it works. So I'll place the point, okay, for a bit further away from the point that you want to evaluate. So if the point, this point, okay, moves closer to the what is that point that you want to evaluate here, okay, so you get the slope, okay, that is closely matched to the exact value, right? Okay, so if you put the point, okay, over here, then you have a steeper slope, right? So if you move along this line, okay, you see that when you reduce h, okay, reduce this h, okay, it will closely resembles to the exact value of the slope. Okay, so the equation is that, okay, the differentiation, okay, is equal to limit h close to 0, okay, f function at x plus h at this point, okay, at x plus h, okay, at some offset point from x, okay. So at this one, so this is actually y, right, y1. This is actually y1 minus fx is y, right? So it is actually the distance between y1 and y. So if I plot okay, if I plot the line over here, okay, so this is actually y1, right? So this is actually y, okay? So what we are seeing here is this one minus this one, which is actually this distance, delta x, correct? Delta x. And this h is actually this one minus this one, right? So this is delta x. So delta y over delta x, you have the slope. Okay, so this is the what's that equation behind? Okay, how to do what is that numerical differentiation at point x. Okay, so far so good. Okay, now so okay, good. So now we want to put this one, okay, into programming. Okay, so now we want to do a differentiation for polynomial functions. Okay, so okay, let me make some notes here, okay, for you to see later. Okay, so so this one you have to put you have to have the habit to put notes in your code, in your source code. Okay, so it's a good habit to have. Why? Because later on when you come back to your to improve the program, or let's say you want to do debugging a few months later. Okay, so when you open the source code, immediately you understand what this code is for, what that code is for. Okay, or you want to pass on the code to somebody else, okay, immediately that guy can pick up what you have written. Okay, so this is a good habit to have, right? So this one, if you put remarks or notes in your source code, it will increase the readability of your code. Okay, so in your assignment, it's good to see this also. Okay, try to put some remarks and notes in your code so that when I read your source code, immediately I can understand what is this for, what is that for. Okay, right. So for this one, okay, I will say numerical differentiation program, right, for polynomial functions. Okay, so for polynomial functions, okay, let me create a new slide here. Okay, so polynomial. Okay, so polynomial functions has some looks something like this. Y is equal to x. What is that? Constant. A is a constant. Okay, plus b times x. Okay, times b plus bx plus c x square, right? Plus what's that? Dx to the power of 3 plus ex to the power of 4, right? Plus blah blah blah, something like that. Okay, so this is a polynomial. Okay, so for a, b, c, d, e, okay, so we call this a, b, c, d, e as what is that? Constants. Okay, we call them polynomial constants or polynomial coefficients, right? So a, b, c, d, e, etc. Okay, are what is that? Polynomial constants. Okay, constants or coefficient. Okay. Okay, so if you look at this one, if you look at this polynomial, okay, you see that degree, this polynomial has a degree of 4, right? The highest degree is 4. So this is a 4th degree polynomial, right? If your polynomial only ends here, okay, ends at x to the power of 3, the maximum degree is 3. So this will be your 3rd degree polynomial. Okay, so degree of polynomial depends on the maximum, okay, power of x. Okay, so so this is polynomial. Okay, so right. So in here, the first thing you need to do is you need to get the user to define, right? So let us construct the pseudocode. Okay, how we want to make this program to happen. Okay, so the first thing that we want is what is that? User. Okay, to define. Okay, let's do this. Define what is that? Polynomial degree, right? Okay, you want to know what is the degree of the polynomial, right? And then define what is that? Polynomial constants, correct or not? Okay, and then okay, third, after that, what do you need to do? You need to construct a polynomial. Okay, polynomial. Okay, using 1 and 2, right? And then the next step, you want to construct what is that? Numerical differentiation, or maybe you just say what is that? Do differentiation. Okay, using differentiation equation. Okay, and then but before that, okay, if you go back and look at the differentiation program, okay, what do you need? You need h, you need x, right? Okay, so construct polynomial, okay, and then before that you have to define, okay, define, okay, the point to do differentiation, okay, then only you do differentiation using the differentiation equation. Then last, okay, the last point you print out what is that? Result. Okay, differentiation result, something like that. So this will be your pseudocode. Okay, pseudocode. Okay, temporary. So when you do your assignment, okay, you should write down the steps like this. Okay, so this is not perfect, but at least it gives you a direction. Okay, and later on we'll come back. Okay, when we develop the program later, then we will come back to refine the pseudocode. Okay, we'll come back to refine the pseudocode. But for now, you know, okay, the first step is to define polynomial degree, right? So this one you have to read from the user input, correct or not? Then later on, okay, you want the user to key in the polynomial constants. What is A, what is B, C, D, E, things like that, right? And then you want to construct the polynomial, alright? Okay, using the user input. Okay, so this one you need to construct. Okay, then after that, you ask the user to key in the point that he wants to differentiate, right? And then you do the differentiation using the equation, okay, using this equation, okay. Then after that you print out the result. Okay, so these are the steps.
Sir?
Yes.
So when you mean the pseudocode, right? That means you have to do like the comments for the assignment, is it?
No, in the pseudocode in your assignment, you have to write it in your report. Okay, the final pseudocode.
So I'll do like the comment and just copy paste in the report, is it?
Yes, you can do it that way. Yes. Okay. But do it properly. I don't want to see this what's that backslash. Okay, in your report. So you just copy pseudocode. Okay, and then the first one is what, second one is what, and so on. You understand me? Okay, you copy the whole thing, paste in your report, but then remove this backslash. Yes. Right? Okay. So first thing you need to do is to define polynomial degree, right? Polynomial degree. So you need to get user input. Okay. So for degree, okay, for polynomial degree, it has to be integer, correct or not? Degree 3, degree 4, degree 5, things like that, okay, cannot be degree 1.5, right? So I'll use integer, okay, for degree, okay, integer for degree, okay, and then I would ask the user, hold on, this one, what's wrong with it? Okay, then I'll ask the user to key in, okay, okay, degree, okay, then, okay, before the user can key in the polynomial degree, you have to tell him what the instruction, right? You have to give the user the instruction. You have to tell him what to key in. So you have to use cout, okay? Cout and say degree of polynomial, okay? Like that. Okay, and then he'll key in degree. Okay, probably he'll key in 3, something like that. Okay. After he has keyed in the degree of polynomial, then you have to ask him to give you the polynomial constants. Okay. Now, so if you look at this one, if you look at the polynomial here, okay, you can have a long polynomial. Okay, you can have a 100-degree polynomial, 10-degree polynomial, and so on. Okay, but then for this exercise, I would like to limit it to 10 degrees maximum. 10 degree, okay, so 10 degree maximum. So I would use what is that, array, okay, I'll use an array, okay, to hold the polynomial constants. So I've not taught you array yet, right? But this is where we'll be learning array. So for the array, okay, I'll use float, okay, and then I'll call what is that, coefficient, okay, coefficient of 11, okay. I have 11 coefficients here. Okay, why I have 11 coefficients? Okay, if you look at this one, I have a degree of 4, I have a 4-degree polynomial, okay, and then I have extra constant a, right? So this is numerical constant a. Then I have coefficient for degree 1, coefficient for degree 2, coefficient for degree 3, and coefficient of degree 4. So in total, I have number of degree plus extra 1 for constant, right? So let's say I want to create a 10-degree polynomial. So the total coefficients that I'm going to get is 11, right? So that is why 11 is here, okay? Right, so coefficient 11, then you have to let the user, okay, to key in the coefficient, okay? So for coefficient, you have to use a for loop, right? Use for loop, okay? Use for loop, and then integer I from 0, okay? I less than 11. Oh, I should use I less than degree, correct? I less than or equal to degree, okay, and then I plus, correct? The rest will be 0, okay? So I would use things like that. Okay, so this one, okay, if I input what is that, no, you need to, okay, before this, okay, you need to let the user cout, okay, you need to let the user knows what the user wants to do, right, needs to do. So you have to input polynomial constant, right? input polynomial constants, okay, end of line, okay, and then for each one, okay, you need to print out, okay, coefficient number I, okay, coefficient number I is, okay, and then that, okay, you have to let him know, what is that, which coefficient he's inputting, right? C in, okay, coefficient number I. Wrong arrow direction, okay, so coefficient I, what does that mean? It means that for A is actually coefficient 0, B is coefficient 1, C is coefficient 2, okay, and so on. Okay, so in programming, so your y will become equal to coefficient 0 plus, okay, coefficient 1, okay, times x, okay, to the power of 1 plus coefficient number 2, okay, times x to the power of 2, okay, plus so on. Okay, so this will become your A, this is B, this is C, right? So this is your this is how it works in programming. Okay, this one I'll put as a note here. Okay, I'll put as a note there. Okay, so let me put another note like that. Okay, so now you have read, you've read the, what is that? You've got the input for degree, okay, and then you use the degree, okay, in your for loop to get the coefficient, okay, to get the coefficient for the polynomial. Okay, and then the next thing you want to do is you want to display, right? You want to construct the polynomial. Okay, so you have asked the user to key in the degree and the coefficients. Now you want to display the polynomial. So what to do? You need to use for loop as well. You need to use for loop. Okay, and I from 0. Okay, I less than equal to degree, okay, and then I plus plus, okay, and then you want to use if, before we move on to that, okay, let us do this, cout, okay, cout what is that, cof I, okay, cof I times x to the power of I, okay, plus something like that. Okay, so it will print out, okay, the coefficient I times x to the power of the degree, okay, plus, okay, for the next thing, right? So if we do this, okay, let's run the program and see what we'll be getting. So degree, let's say I key in degree of 3 polynomial, okay, so the first coefficient is 2, okay, then 2, 1, 3, let's say, okay, so I'll be getting 2 times x to the power of 0, right, plus 2x power of 1 plus 1x power of 2 plus 3x power of 3 plus, okay, so if we check, so this will look like 2, okay, x to the power of 0 is 1, right, 2 times 1 is 1, 2 times 1 is 2, right, so this whole thing will become 2, okay, so that's coefficient A, okay, and then 2 times x to the power of 1. So x power of 1 is x, right? So this will read 2 plus 2x plus x power of 2 plus 3x power of 3 plus blah blah. Okay, so this plus we should take away, right? We should remove this one. So now we have got the basic structure. Okay, so what we need to do next is we want to remove, we want to what is that, give it a proper display, right? So if, okay, I is equal to 0, okay, if I is equal to 0, okay, so if I is equal to 0, then I don't need x, right? So I only need the coefficient. Okay, then I will do this. Okay, coefficient plus. Okay, coefficient with a plus. Okay, else if I is equal to degree, okay, if I is the last one, okay, if, wait a minute, okay, if I is 3 is at the degree index, okay, is at 3, then I don't need to have plus at the back. Okay, then I'll print out this one. Okay, ENDL. Okay, else, okay, otherwise, if I is not at the beginning, if I is not at the end, then I'll print out this whole thing. Okay, for example, right, I'll do it this way, right, like that. Okay, so if I hit enter and run the program again, okay, degree of polynomial is still 3, so 1, 2, 3, 4. Okay, now I've got 1 plus 2x1, okay, 2x power of 1 plus 3x power of 2 plus 4x power of 3. Okay, so you can do it this way. Okay, so this is how you display. This is how you can display, okay, the polynomial. Okay, you can also make a, what is that, make a subroutine, okay, the sub function for this one. Okay, so you don't want to make your what is that, main program too bulky, so I'll need to use void function, okay, for that one. So I'll use void, okay, display polynomial, display poly, something like that. Okay, so display poly, I will need to use the coefficient, correct, and I will need to use degree, right? So for coefficient, float, okay, coefficient 11, okay, and then integer degree, right? And then I'll copy the whole thing here, cut and paste, okay, like that. Degree, okay. Okay, and then I'll call in my main function, okay, display poly. Then I'll give it coefficient and degree. Okay. Okay. So this one, okay, you see this one coefficient 11, okay, coefficient with 11 elements inside, okay, and then you're passing this coefficient, okay, into this function, right? Okay, if I run the program, okay, So degree of polynomial is 3. Okay, coefficient is 1, 2, 3, 4. Okay, and still get the same output. Okay, so for this one, I'll put a note. Okay, to display the polynomial. Okay, right. So the next one. Okay, so the next one, now you have got the, okay, oh, not this one, it's here. Okay, so we have constructed the polynomial, okay, using 1 and 2. Okay, now we want to define the point to do differentiation. Okay, we need to get the x. Okay, the point x, so we need to get this point. Okay, this point. Okay, so the user, we have to key in. Okay, I want to do differentiation at x, okay, so he'll key in x. Okay, and then the function, the program will give what is y. Okay, what is the value for y? The user will key in the value for x. Okay, and then the program will spit out the value for y. So, but we don't have a function to do that yet, right? So we have to create a function for that. Okay, but okay, before that, okay, we need to ask the user to key in cout, okay, input x, input, what is that?
Value for x.
Yeah, input, how to say, input x, okay, for differentiation. Input value, okay, input value for x, okay, for differentiation, something like that. Okay, cout. Okay, and then you read cin. Okay, you assign to x. Okay, but x is not defined yet, so you need to define what is x. You need to declare. So x should be a floating point number, right? Float x. Okay, my mistake again. Cin, wrong direction, like that. Okay, so once the user has keyed in x, okay, and then you need to use this x, okay, to get y. Okay, to get function, to get what's the value for y. Okay, so now we have to use this one, float y is equal to 0, right? And then what is that? For, you need to use for loop, integer I is 0, okay, I less than equal to degree, okay, I pass, okay, like that. So if you see from this equation, okay, y starts from 0. Y is actually this one plus this one times x plus this one times x squared and so on, right? So you can actually use a for loop, okay, with y starting from 0, okay? So the first loop is 0 plus a, correct or not? Then you get a. In the second loop, okay, you have y is equal to a plus b times x, okay? Then you get what is that? The total value for a plus b. Okay, if you look through, okay, you get the whole summation for this one. Okay, so let's do this. So y plus equal to, okay, so in programming it works this way. What y plus equal to, okay, coefficient I, okay, times x. Okay, as simple as that. So when I is equal to 0, coefficient 0 times x, okay, times x to the power of x to the power of I, right? So this is the right thing to do. Okay, so you see how if you look at this one, okay, so y is actually this one plus this one plus this one plus and so on, right? So it means that y starts from 0. The first loop will be 0 plus, okay, a times x to the power of 0. Anything to the power of 0 is 1. Okay, 5 to the power of 0 is 1. 10 to the power of 0 is 1. X to the power of 0 is also 1. 0 to the power of 0 is also 1. Okay, so this is our basic mathematics. Okay, plus b, okay, times x to the power of 1, right? Anything to the power of 1, okay, is that thing. Okay, 10 to the power of 1 is 10. 100 to the power of 1 is 100. Okay, 0 to the power of 1 is 0. Okay, I hope you remember. Okay, so if we do it this way, okay, so in what is that, in programming we can do it this way using for loop. It's simple. Okay, then we can print out, okay, after you look through, okay, you can print out y. Okay, let's say y is equal to something like that, y dndl. Okay, let's try. Need to turn this off. Okay, run again. Let's try a second degree polynomial, a 1 degree polynomial. 1 degree polynomial is actually a linear function, right? Linear equation. So the first coefficient is 1, okay, and then 2 is the slope, right? Like that. Okay, so if you input value x for differentiation, or put 1, okay, you have y is equal to 3. We have not done the differentiation yet. Okay, we are simply getting the value for y. Okay, if you check, 1 plus 2 times 1 is 3, right? 2 times 1 to the power of 1 is 2. Okay, 2 plus 1 is 3. Okay, so let's check again. Okay, now this time we use a second degree polynomial. So 1, 2, and 3. Okay, if I put 5, okay, I'll get 86. Okay, you can check out. So 1 plus 2 times 5, 10, right? Now you got 11. Okay, 25 times 3, you have 75. 75 plus 11, you have 86. Correct. Now I'm happy. Okay, now I am happy. Okay, so the next thing you need to do is to convert this one into a subfunction. Why? Later on we want to use the same thing, okay, to calculate for another point as well. Okay, for this point also. Okay, so we need to get this y also, right? Given an offset for x, okay, and then what is the value for that y? Okay, so I don't want to make my code too long, so I will need to convert this one into a function. Okay, so this will be a float function. Okay, float function. This one will be a polynomial function, right? So I'll call the function polynomial, and I'll put the whole thing here. Okay, and then I'll need to give the coefficient. Okay, the coefficient will be in float. Okay, coef 11, right? And then the float, okay, for degree, right? And then I'll need to give a float, okay, for x. Okay, so the user you need to pass these three arguments into this polynomial function to do this. Okay, then this function, it will return the value, okay, of y. Okay, you print out y and then you return the value of y. Right, so I will do this here. Okay, I'll use a float. Okay, y is equal to polynomial, okay, and then coefficient degree and x. Okay, so this one. Okay, and then I'll need to get another value for this guy as well. Okay, then I'll need to define age. Okay, so this age you can define yourself in this program. Okay, so I will need to define age as float. Okay, age is equal to 0.001. Okay, any number that is small enough. Okay, you can start with 0.1. Okay, then you can check the answer. Okay, so if you look at this equation, okay, the limit h is close to 0, right? Close to 0 means the h has to be extremely small. Okay, how small we don't know, we check. Okay, so we start with 0.1. Okay, so the equation to do differentiation is this one, right? So we need to get this value. Okay, f x plus h, okay, is this y. Okay, we have got this one, we have got this one, we just defined. Okay, now we need to get this one. So your x1, okay, float x1 is equal to x plus h, right? X plus h, this one. You need to have this one, then only you can put in the function, okay, to find this one, y1. Okay, so if you do that, okay, x1 is x plus h, then you can find float y1 is equal to polynomial, okay, coefficient, degree. Okay, now we give x1 into the function. Okay, okay, like that. Okay, so if we check the output, okay, we'll see that, okay, degree of polynomial, let's say it's 2, okay, coefficient is 1, 2, 3, okay, the input value for x for differentiation, let's say is 3, okay, now you see, okay, so your y, y at 3, right, y at 3, okay, you get 34, okay, so y at 3.1, okay, because delta h is 0.1, right, so your y at 3.1 is 36.03, okay, so this is your y1, okay, so you can do differentiation now, right, so your differentiation, okay, is float, okay, differentiation is equal to, you can call it slope, differentiation is actually slope, right, slope of the curve. Slope is equal to delta x delta y divided by delta x. So your delta y is y1 minus y, correct? Divided by x1 minus x, right? x1 minus x, correct? If you look at this one, okay, so it's actually y1 minus y, okay, you get this vertical difference, okay, and then divide by x1 minus x, you get this difference, but this difference is actually h, right, 0.1, okay, so instead of this one, I can simplify it and make it h like that. Okay, and then I can check C out. Okay, the slope is equal to slope. Okay, PNBL. You run and print the result. Okay, let's try with 1. Okay, degree of polynomial is 1, so this is what's that, linear function. Coefficient 0 is 1, 2. Okay, you want to differentiate at point 2. Okay, so now you see, okay, this is what is that, y is equal to 1 plus 2x. So the slope is 2, right, for linear function. So you see, I get slope is equal to 2 as well. Okay, what if I want to increase to another value? Let's say if I increase, not increase, actually I decrease, okay, decrease this h, okay, to a smaller value. Okay, now I want to check whether I'll get the same value or not. Okay, so if degree of polynomial is 3, okay, then coefficient is 1, 2, 3, 4, okay, 2. Okay, now I get the slope is 61.0352. Okay, so for degree of polynomial 3. Okay, now let's go back to what is that, the what is that, 1 degree polynomial, the linear function. Okay, just now we had 2 and 2, was it? So I put 2 for this one as well. Okay, the slope I get is only 1.91. I should be getting 2 actually. Okay, so I should be getting 2. So you see that there's a small difference here. There's a small difference here. Okay, so when you do the, what is that, finite differentiation, okay, so you need to choose the right h. Okay, you need to choose the right h. Okay, so but how to choose the different the right h, so that is beyond the scope of this topic. You actually have to what is that, do what is that, optimization. Okay, you want to find the h so that the slope that you get is consistent, okay, for several values. Okay, so you try to, basically you just try to increase or decrease this number, okay, until you get a consistent slope. Okay, until you get a consistent number. Okay, so once you have reached a consistent number, we say that you get convergence. Okay, so once you get convergence, then the slope that you get is the correct one. Okay, so if I try to reduce this one a little bit more, okay, then I run the program again. Okay, I'll see a different value, but then it will become closer to the true value. 1, okay, 2, 2, and 2. Okay, now you see it's reaching 2, right? It's reaching 2. Okay, if I reduce a little bit more, okay, it will become 2. Okay, so in reality, okay, you need to write another function. Okay, you need to try to reduce this one or increase this one until you get a constant value. Okay, but for exercise, okay, to illustrate how it works, this is enough. Okay, right, so basically this is it, okay, for numerical differentiation.